Okay, so you notice with question 2, all right, that they just look at the mass of the crate, okay, that rests on the lift floor. They don't tell us the mass of the lift, right? But that doesn't matter, right? We don't necessarily need it. It depends on what the question is asking for. Okay, so they say this crate of mass 25 kilograms, so that means obviously it's got a weight then of 25 G. It sits on this floor of a lift, which is descending. So descending means it's going down, of course. So we'll have the acceleration pointed downwards here to show the direction of motion. Okay, and he says then find the reaction of the floor of the lift on the crate. Well, of course, there is going to be a reaction, right? Because if you've just got that force acting downwards, this crate is going to just keep falling, okay, to the centre of the earth. It's going to keep going because gravity is attracting it. Yeah, that is a force there attracting it to the centre of earth. But it's not falling, okay, it's staying in that lift because essentially that floor is strong enough to hold it in place. Okay, so it's almost as if the floor is pushing up. Okay, think of it that way, it's pushing it up to keep it in place. So there's a reaction there. Okay, now we know the acceleration is 1.2, it says in part A. Right, so we want to find the reaction. So if we use Newton's second law in the direction of motion, okay, so always consider the way the lift is actually going, right? Whether it's accelerating or whether it's descending, decelerating rather. Okay, it could be decelerating to a stop. It doesn't matter. You always look at the direction it's going in. So we've got here the weight, which is 25 G. Okay, which is taking it. The lift's going down. So that's the leading force. Take away the reaction. Okay, equals to then the mass times acceleration. Okay. So in this case then, of course, we know G is 9.8. We want to work out the reaction. We know the mass is 25 and we know the acceleration is 1.2. So all you've got to do there then is rearrange this. Okay, so 25 times 9.8 is 245. 25 times 1.2 is 30. So if we rearrange that, we get 245, take away 30, which is 215 newtons. So that's a reaction there from the floor of the lift. In part B, it says the velocity of the lift is constant. Okay, well, if the velocity of the lift is constant, and they want you to find the reaction, well, that means then there's zero acceleration. Okay, so we must appreciate that. So even though it's going down, it's going at a constant speed. Okay, which leads us to say the acceleration is zero. So velocity constant implies then it's not accelerating. Velocity staying the same. So when we use Newton's second law here, we have 25 G, okay, take away R, but the resultant force then will be zero, won't it? Because acceleration is zero. So it'll be 25 for mass times 0 for acceleration, which will give me 0 here. That means then, quite simply, that R has got to equal 25G. So R will actually match the weight, okay, which is 245 newtons when you work that out.